Today I'll be discussing the role of nicotinic acetylcholine in Alzheimer's disease. So what is Alzheimer's disease? It is a disorder that contributes to dementia and entails the accumulation of extracellular plaques in the brain, which are caused by B-amyloid, a toxic protein for neurons. This leads to the death of neurons and long-term neurodegeneration, which impairs memory and cognitive abilities. Nicotinic acetylcholine is a ligand-gated ion channel receptor that is involved in the nicotinic acetylcholine signaling pathway. It has two binding sites, extracellular binding sites, for nicotine and acetylcholine, hence its name. Upon binding, the receptor channel opens up to allow the flow of calcium ions. These ions are the second messenger for the entire nicotinic cholinergic neurotransmission. What happens during transduction? So, scaffold proteins that are involved in transduction are the PDC-containing proteins that make up the PSD95 family, which regulate cellular response, as well as the APC scaffold protein and transmembrane proteins. Furthermore, protein kinases play a critical role in the regulation of the phosphorylation that occurs in the receptor signaling pathway. Butyrylcholinesterase and acetylcholinesterase are what terminates the pathway signaling by hydrolyzing its transmitter. What happens exactly to the receptor and the signaling that links to Alzheimer's disease? Abnormalities in the receptor signaling contribute to the loss of neurons, particularly those that are involved with the receptor. A protein toxic to neurons is the A-beta, causes the death of them by plays a critical role in the progression of Alzheimer's, as can be seen by the evidence of deposits of this protein in patients with the disease. This protein affects the cholinergic signaling involving the receptor. Furthermore, nicotine, which is a ligand for the receptor, protects neurons and prevents neuron death caused by these toxic proteins. So the tyrosine kinase pathway, such as the P13 AKT pathway, is linked to the nicotinic acetylcholine receptor and plays a role in neuroprotection, which prevents cellular death. Inhibitors of this family of kinases block the neuron's protection from AB proteins. Furthermore, tyrosine kinases like FYN and SRC also play an active role in linking the P13K/AKT pathway and the receptor to achieve neuroprotection. Without their function, neurons lack protection from toxic AB proteins. Furthermore, with the presence of the AB protein, they cause hyperphosphorylation. Here's a normal nicotinic acetylcholine pathway. As you can see, the normal routes of the pathway show that the gene transcription is for anti-apoptosis. This is when the nicotine is what is attaching to the receptor. This is when an AB protein induces apoptosis. So the AB protein will attach itself, or the actual ligand would be the nicotine, and instead of promoting anti-apoptosis, it promotes the gene transcription of apoptosis. It does such by inhibiting the normal and healthy processes of the P13ATK pathway and MEK and ERK pathway, as well as the JAK STAT pathway.